Let's take a look at the overflow flag and the carry flag at the same time to get a better understanding about the difference of those two flags. Both of the flags will change in every arithmetic operation. The point is that the processor doesn't care about your interpretation of the bits. Those flags are going to change anyway. It is your responsibility as a programmer to look at the relevant flags. Which flag to look at? That actually depends on how you interpret your numbers. If you work with unsigned numbers, you only care about the carry flag. If you work with signed numbers, you only care about the overflow flag. I just want to stress this idea. It is kind of a philosophical idea. Some people really cling to the meaning of the numbers. Usually people that come from higher level programming languages, they are used to having a type attached to every number, which is reasonable in higher level languages. However, in assembly, you don't have a type attached to every number. The numbers are just bits. You probably know this by now. The processor doesn't really understand numbers the way you understand them. He only sees bits. He can only see zeros or ones. It has some special mechanisms that actually give him a semi-understanding of what is a positive number or what is a negative number. However, he doesn't really understand it. Those mechanisms are, for example, the overflow flag and the carry flag. The carry flag is some kind of indication of wraparounds that happen when you add things. And the overflow is some kind of indication of errors that happen when you do arithmetic, for example, addition or subtraction with signed numbers. The processor doesn't really care about it. It cares about it so little that there is only one bit to represent it. Only one bit to represent wraparounds in unsigned arithmetic, and only one bit to represent overflow in signed operations. It is your job to look at those flags, if you care at all. If your program is about unsigned numbers, or maybe the current chunk of code that you work with is about unsigned numbers and you just add unsigned numbers, the overflow flag is going to change too, because the processor doesn't know that you work with unsigned numbers. It is your responsibility to look at the carry flag when you work with unsigned numbers, and it is also your responsibility to look at the overflow flag when you work with signed numbers. Let's try to do some more advanced comparison, just to make sure that you understand the difference between the carry flag and the overflow flag. What we have here is 4 different chunks of code. For every different chunk of code, we are going to try to understand what is going to be the result, and also how the flags are going to be affected. I'll remind you that both of the flags are going to be affected no matter the operation you do. Even if you only care about unsigned numbers, the overflow flag is going to change too, for example. So let's take a look at the first chunk of code. Try to follow me on this, and also try to predict yourself the resulting values and the resulting flag in each example. In the first example, we move the value 0 inside EAX, and then we subtract 1 from EAX. Can you try to guess the carry flag and the overflow flag? Good. So the result is going to be EAX equals 8Fs, which is actually some kind of wraparound. We subtracted 1 from 0 and a wraparound occurred. That's why the carry flag was set to 1. The overflow flag is cleared. Why is that? we have this number 0, and we subtracted the number 1 from 0. So actually we subtracted positive minus positive, which resulted in a negative number. I'll remind you that this is one of the cases where the overflow flag is always cleared, because positive minus positive can be both positive or negative. The processor cannot predict what kind of result you are going to get. Because we have here positive minus positive, the overflow flag is 0. Let's look at the next example. Here we store the value 7f inside DL, and then we add 1 to this value. Take a moment to try to predict the carry flag and the overflow flag after the execution of this code. Good. We have the result of DL equals 80, which is mostly expected. We just added 1 to this number. And we have that the carry flag is 0 and the overflow flag is set to 1. Let's try to explain. We actually didn't have any kind of unsigned overflow here. This number is of size 8 bits, and this number is also of size 8 bits. We added those two numbers, and the result actually fits inside 8 bits. So we don't have any kind of overflow here, and the carry flag is cleared. Let's talk about the overflow flag. This number, 7f, is positive. The number 1 is also positive. We added those two numbers, positive plus positive, and we got this result, 80, which is negative. It is negative because the most significant bit of this number is 1. So this result is not reasonable in the sense of positive and negative numbers, in the signed sense. Therefore we have overflow flag set to 1. Let's look at the next example. Here we store the value 5 inside AX, the value 4 inside SI, and we add those two numbers. Take a moment to try to predict the values of the flags after the execution of this code. Good. The value that we have inside SI after the execution of this code is 9. And we can see that the carry flag is cleared to 0 and the overflow flag is cleared to 0. Let's try to explain it. We added those two numbers. I remind you that AX is of size 16 bits and also SI is of size 16 bits. So we added those two numbers and we got the result of 9. It seems that the result actually fits inside the bounds of 16 bits, so no wraparound has occurred. Therefore the carry flag is 0. Let's talk about the overflow flag. The first number here, 5, is positive. Also 4 is positive. And the result 9 is positive, which is a reasonable result. Positive plus positive equals positive. That is why the overflow flag is clear. Let's take a look at the last example. Here we have this chunk of code where we first move 80 inside CL, then we move 80 inside DL, and finally we add those two numbers. Take a moment to try to predict the result and also the expected values of the flags. Good. So the result in CL, which is mostly expected, is 0. Why is that? Because 80 plus 80 is going to be 100 in base 16. You can even do this calculation on a paper. It equals 100. However, only the 8 lower bits are allowed inside CL. Therefore, CL is only going to contain 0. So, Here we actually have a wraparound in the addition operation. Therefore, the carry flag is going to be 1 because of the wraparound. If there weren't a wraparound, we would have the result of 100, but we don't have it here. We only have the result of 0. That's why the carry flag is 1. About the overflow flag, we have those two numbers, 80 and 80, that we just added. The first number, 80, is negative. It is negative because the most significant bit in this number is 1. The next number, 80, is also negative. We added those two numbers and the result was 0. The number 0 is positive. So, the result we got is not really reasonable in the signed sense. That is because we added two negative numbers and somehow we got a result of a positive number, which is not reasonable. Therefore, the overflow flag tells us about it. The overflow flag is set to 1. This is a very special example because both the carry flag is set to 1 and the overflow flag is set to 1. I think it's a very nice one to remember the meaning of the carry flag and the overflow flag. Summary of the things that we have learned in this lesson. The 0 flag is 1 if and only if the last result was 0. The sign flag is 1 if and only if the last result was negative. The carry flag is 1 if and only if the result, considering unsigned numbers, is wrong. The overflow flag is 1 if and only if the result, considering signed numbers, is wrong. I also want to remind you that all of the flags change in every operation that you do, in every arithmetic operation that you do, and also that the processor doesn't really care which flag you care about. Actually, the processor doesn't know if you work with unsigned numbers or with signed numbers. It considers that you might want to look at the carry flag or the overflow flag or each of the other flags. So it calculates all the flags every time. We are going to use the information that we got here in the future to be able to take sophisticated branches and to take interesting decisions in our program. So make sure that you understand the meaning of each of these flags. It is possible that at this point you still didn't fully grasp the meaning of the carry flag and the overflow flag. Don't worry about it. In the future we are going to talk a bit more about these flags and you are going to be experts about these flags. See you next time.